Have you ever really thought about what happens when you click book on a flight? It feels so simple, but it's not just one transaction. It's it's like a global symphony of computer systems all working together in perfect time. So in this explainer, we're going to pull back that curtain and show you the incredible engineering that happens behind every single airline ticket you buy.
First, let's just try to get our heads around the scale of this thing. During peak travel times, a big airline's booking system might be handling requests from over 2 million people at the exact same time. That's like the entire population of Houston, Texas, all trying to snag a seat at once. It's just massive.
And that leads us to the fundamental challenge, this huge, high-stakes problem. How do you sell something totally unique, like one single seat on one specific plane, to millions of people simultaneously, without ever making a mistake? Because one tiny slip-up means two people show up at the gate for the same seat, and that's a nightmare nobody wants.
Yeah, for the engineers who build these platforms, it really is a monumental task. The margin for error is effectively zero. The system just has to be perfect, 24/7, 365 days a year, no exceptions.
So these are basically the 5 commandments they live by. First, high availability. We're talking 99.99% uptime. That means less than 1 hour of downtime for the entire year. Then, low latency. You want those flight results in under 2 seconds, right? Of course you do. Third, and this one's the magic ingredient, strong consistency. This is what stops overbooking, and we're going to dig into that in a minute. And of course, the system has to scale up for the holiday madness and keep all your payment data locked down and completely secure.
Okay, so let's actually trace the journey of your request. We'll follow it right from the moment you hit search all the way to that beautiful confirmation email landing in your inbox.
The second you hit search, your request flies out to a load balancer. You can think of this like a digital traffic cop, directing all the incoming requests to the least busy server to keep everything moving super fast. From there, it hits an API gateway, which is kind of like a bouncer at a club. It checks your request's credentials, makes sure it's legit, and finally, your request arrives at the flight search service. This is where the real work begins.
You know, this maitre d' analogy on the slide is actually perfect. The API gateway doesn't just check you in, it knows exactly where to send you. It greets your request and then guides it to the right table, which in this case is the specific internal service designed to find your flight. It's a super important step for keeping everything organized, efficient, and secure.
So how does it find all those flight options so ridiculously fast? Well, it's a really clever trick. For common trips, like say New York to Chicago, the system uses cached results. That means it's already figured out the best options ahead of time and has them ready to go. It's not the live, up to the millisecond data, but it's super close and it makes the search feel instantaneous. The final, perfectly accurate check on seat availability, that happens right at the very end when you go to book.
All right, now we're getting to the really exciting part. We're moving from just browsing to the actual race for a seat. And this is where a single millisecond can change everything.
Come on, we've all felt this. You found the perfect flight, the price is amazing, and then you see those 4 little words, only one seat left. And your heart just starts racing, doesn't it? The pressure is suddenly very real. There's no time to think about it. You just smash that book button, hoping you're fast enough.
But here's the catch. You're probably not the only person who wants that seat. Somewhere else in the world, someone else is looking at the exact same flight for the exact same price, and they're about to click the exact same button.
So this is it. This is the moment of truth. 2 people, 1 seat. Who wins? And the answer is strong consistency. This is that non-negotiable, unbreakable rule we talked about. There is a dedicated inventory service that acts as the single authoritative source of truth for every seat. When you click Book, your request gets put into a queue. The system processes these requests in the exact order they arrived. The first one in gets the seat, period. The second request, even if it was just a fraction of a second later, gets a "sorry, it's gone" message. It's how they absolutely guarantee a seat is never sold twice. So, congratulations. Let's say you were the faster click. You got the seat. But the system's job isn't done yet, not by a long shot. Now it's time to make this thing official.
And just like that, a perfectly choreographed sequence of events kicks into gear. First, the inventory service officially locks down that seat for you. Immediately, the payment service jumps in to securely handle your credit card. At the same time, the booking service is creating your official passenger record, your PNR. Then, the notification service fires off that confirmation email.
And finally, the system broadcasts out to the global distribution systems, telling every travel agent in the world that your seat is now off the market. Each of these services is like a member of a Formula One pit crew. You've got one person just for the payment, another just for the booking record, another just for notifications. They each have a highly specialized job, but they have to work together in perfect harmony to get the whole thing done in just a couple of seconds. It's absolutely seamless.
So now that we've seen all the pieces in action, let's kind of zoom out and look at the bigger picture. Building a system like this is all about making really smart design choices and balancing a whole lot of competing priorities.
And this table here illustrates those trade-offs beautifully. For instance, using what are called microservices lets them scale up different parts of the system independently. That's a huge win, but the challenge is, now it's way more complex to manage all those little moving parts. Or what about strong consistency? The benefit is crystal clear, no overbooking. The trade-off? It can be a tiny bit slower than a system that's less strict. It's always a balancing act.
And you see that same balancing act with how they store all the data. It's not just one giant database. Instead, they use different types of data stores for different jobs. For your personal info and booking record, they use super reliable relational databases. But for the flight search itself, they use a specialized search index that's built for pure raw speed. And for that critical seat inventory, that gets its own high-integrity database designed to be that single source of truth. It's all about using the right tool for the job.
So when you put it all together, what's the big takeaway? Well, it's that the one simple click you make, it's actually a pretty big deal. It's a global event.
The next time you book a flight, just remember what's happening. It's not just a purchase. It's a perfectly choreographed dance between dozens of independent, highly resilient systems. It's this beautiful symphony of engineering that's happening completely out of sight, all to make sure you get to where you're going.
And that really makes you wonder, doesn't it? What other simple clicks in your day-to-day life are powered by this same level of invisible, complex engineering? When you order food delivery, stream a movie, or call for a ride, you're tapping into this hidden world of incredible complexity. It's a great reminder that sometimes the things that look the simplest are actually the most sophisticated of all.